In this video lecture, we will talk about circles. Before we start talking about the conic section circle, we would like to talk about an algebraic process which is called completing the square. To start, think about a quantity square. So say I have quantity 1 plus quantity 2 and I square them, then I'm supposed to get the first quantity square plus 2 times the first quantity times the second quantity plus the second quantity square. And if I have first minus second to the power 2, then I'm supposed to get first quantity square minus 2 times first times second plus second quantity square. Based on these two formulas, whenever we are given with a general form, say ax square plus bx plus c, and we want to complete the square, our usual process is trying to write down the ax square term as square root of a times x whole to the power 2. Since the first quantity is square root of a times x, now I will write 2 times the first quantity, square root of a times x, times, now we will write down something that will eventually change this term back to the original term bx. Think about writing b over 2 square root of a. Then what happens? You can cancel this 2 square root of x and this 2 square root of a and eventually get bx. Once I have done that, I will now write the square of the second quantity, which now is b over 2 square root of a. But since this was not in the original format, I will subtract that as well. And write down the given term plus c. What we have thus far, if I look at the first 3 terms, then that is the quantity whole square, or in other words, I can simplify that by writing square root of ax plus b over 2 square root of a whole to the power 2 minus b squared over 2a, or actually this one is 4a because you have to square both 2 and square root of a, plus c. And this is called completing the square. Now, if we initially have started with ax squared minus bx, then I will keep the entire work the same, except the middle term 2 times quantity 1 times quantity 2, I will make it minus, and inside the whole quantity square, instead of plus, we will get a minus. So now, let's go to our lecture note and keep working on our problems. The general equation of a circle is given by ax squared plus by squared plus cy plus d equal to r squared. The standard form of the circle is given by x minus h whole squared plus y minus k whole squared equal to r squared. And the standard form is easier for us because it directly computes the center of the circle as h comma k and the radius equals r units. The diameter of the circle is the longest secant line segment, portion of the straight line that crosses the circle in exactly 2 points, that can be drawn. It always passes through the center of the circle and the diameter is twice the length of the radius of the circle. So let's work on some completing square first. The first one is x squared plus x plus 5. Now this one you will write as x squared plus, I need 2 times quantity 1, which is x. To make it back to original plus x, I will have to multiply 1/2. So that's my quantity 2. So now I add quantity 2 square, subtract quantity 2 square, and then keep writing the given terms as plus 5 equal to 0. So now look at the first 3 terms, that is x plus 1/2, the whole quantity square, minus 1/4 plus 5 equal to 0. And at this point, you can write it as x plus 1/2 to the power 2. 5 minus 1 over 4 is 19 over 4, and I can take it to the other side as negative 19 over 4, and that will be completing the square. And this is what we will require to do when we are given with the general form of the circle and we wanted to understand the radius and the center of the circle. X squared minus 6x minus 1 is our next example. It's easy. You do x squared minus 2 times quantity 1. How much more I need? Well, I need a 3. So I need to add 3 squared, subtract 3 squared, and then minus 1 equal to 0. So first 3 terms again is x minus 3 whole to the power 2. And then I have minus 9 and minus 1. I will take it to other side. So I will say x minus 3 whole to the power 2 is equal to 10. Is the point negative 4, 15 is on the circle defined by x plus 4 whole square plus y minus 15 whole square equal to 100. So what I need to do, I need to put x equal to negative 4. So I will get negative 4 plus 4 whole square. Y equal to 15. And ask myself, after I square and add, is this going to be equal to the right hand side? Well, see, this one is 0 square plus 0 square, which is 100. So they are not equal. So no, negative 4, 15 is not on the circle. In fact, this is the center of the circle. The reason we did this problem is for us to understand that when we talk about a circle, we talk about only this boundary line. The area that is bounded by this circle is called a circular region. The center, being inside the circular region, is not on the boundary and hence is not on the circle. Determine the radius and the center of the following circles. So the first one is pretty simple. It's in the standard form. You just have to write it as x minus 6 to the power 2 plus y minus minus 4 because it was a plus and I need to write it as y minus something. So that equal to 6 squared. Hence I get to say center of this circle is 6, negative 4. Radius of this circle is 6 units. Our next problem, pretty similar. Write it as x minus 6 over 5 whole to the power 2 plus y minus minus 5 over 3 whole to the power 2 is equal to 3 over 7 whole to the power 2. So the center of this circle in the standard form is given by 6, 5, negative 5 over 3, whereas the radius of the circle is given by 3 over 7 units. So these problems, both of them are actually pretty simple because we have the standard form. But we will not necessarily be given with the standard form of a circle. In that situation, the general form will be given to us and we will complete the square twice, once for x, once for y, and get the equation of the circle. We will remember, if after completing the square, we find that the right hand side is a negative number or the radius is imaginary or a complex number, then the equation doesn't give me a circle. It is called a degenerate equation. So first and foremost, a degenerate equation, you have to complete the square and then the right hand side must be a negative number and then it is not a circle. A circle is a non-degenerate general equation in terms of x and y. So let's work out these problems. So first what I do, since there is only one x term, I know that it is already completed. For y, I would write it as y squared minus 2 times y. I need 5 more. So now I need to do 5 squared minus 5 squared minus 67 equal to 0. Then x squared, write it as x minus 0 whole to the power 2. For y, you write y minus 5 whole to the power 2. Then you have negative 25. You take it to the other side, so that's a positive 25 and positive 67. So x minus 0 whole to the power 2 plus y minus 5 whole to the power 2. 7 plus 5 is 12. 2 plus 1 is 3 plus 6 is 9. Which you can write as square root of 92 whole to the power 2. And that tells me that when I write the center of this circle, first and foremost, this is non-degenerate as the right hand side is positive and the center is 0, 5. The radius is square root of 92 units. And if you remember, 92 you can write as 4 times 23. So I can write it as 2 times square root of 23 units. Answers my question. X squared plus y squared minus x minus 5 over 2y plus 1 over 4. So it is that situation where you have to complete square for both x and y. So let's write it as x squared minus 2 times x. To make it negative x, I need to multiply 1/2. So I'm going to add 1/2 square, subtract 1/2 square, plus y squared minus 2 times y times. To make it negative 5 over 2y, I need to multiply 5 over 4. So I need to add 5 over 4 squared and subtract 5 over 4 squared. And then I had this plus 1 over 4 equal to 0. So there are a bunch of terms. Let's see. The first 3 terms in terms of x will be the quantity x minus 1/2 whole to the power 2. Then I have negative 1/4. Then I have plus y minus 5 over 4 whole to the power 2 minus 25 over 16 plus 1 over 4 equal to 0. So clearly this plus 1 over 4 and negative 1 over 4 will cancel each other, and I will get x minus 1/2 whole to the power 2 plus y minus 5 over 4 whole to the power 2 equal to 25 over 16. Write it as 5 over 4 whole to the power 2. And that tells me center for this circle is now clear. It's 1/2 comma 5 over 4. Radius of this circle is 5 over 4 as well. Find the equation of the circle that has the center at 4 comma negative 6 and the radius is square root of 13 units. Well, I will write x minus 4 square plus y minus minus 6 square equal to square root of 13 square. So in standard form, it looks like x minus 4 square plus y plus 6 square equal to 13. If I want to give it the general form, then I will FOIL, get x squared minus 8x plus 16 plus y squared plus 12y plus 36 minus 13 equal to 0. So I get x squared minus 8x plus y squared plus 12y. And combining the like terms, 16 minus 13 is 3 plus 36 is 39. So plus 39 is equal to 0. Answers my question. And then similar problem. Find the equation of the circle that has a diameter with the following endpoints, negative 2 and negative 10 and 10 and 6. So remember, in the circle, diameter is the largest secant line that passes always through the center. And these points are 10, 6 and negative 2, negative 10. So first I need to know the length of the diameter. So the length of the diameter is the distance between these two given points. So that is going to be 10 minus 2 square plus 6 minus 10 square, and then finally I take the square root of that. So I get 10 plus 2 is 12 square plus 6 plus 10 is 16 square, and the square root of that. 12 squared is 144, 16 squared is 196, that's 14 squared, I'm so sorry. 16 squared is 256. And when I add them, I get 400. Square root of 400 is 20, so now I know that diameter is 20. Radius is half of the diameter. So that's 10 units. Center is half the way between the 2 points at the extremities of the diameter. So center is going to be the midpoint, which is 10 plus negative 2, the two x's you add them and divide by 2, comma 6 plus negative 10 over 2. The same thing with y. So this is going to be 10 minus 2. So 8 over 2 is 4, comma. 6 minus 10. So negative 4 over 2 is negative 2. So the equation of the circle is what I want. And I will say that the equation of the circle is x minus 4 square plus y minus 2 square equal to the radius 10 square. So I get x minus 4 square plus y plus 2 square equal to 100 as the standard form of the circle. Then, as you know, you can FOIL this thing and get the general form. Word problem. A cell tower is a site where antennas, transmitters and receivers are placed to create cellular network. Suppose that a cell tower is located at the point 1, 4. So it clearly is talking about the plane. So let's go ahead and do 1, 4. X equal to 1, y equal to 1, 2, 3, 4. So somewhere here on a map, and its range is 2.5 miles. So you are going to think about a radius of 2.5 miles along this circle. So let's see. It's something like this. Let me actually do it a little differently. So something like that, where I know that the radius is given by 2.5 miles. The question is asking us, write an equation in terms of x and y that represents the boundary of the area that can receive the signal from the tower. So basically find the equation of the circle. So the center is 1, 4. It's been given to us that 1, 4 is the center. So we'll say it's x minus 1 to the power 2 plus y minus 4 to the power 2 is equal to 2.5 the radius to the power 2. So I get to say x squared minus 2x plus 1 plus y squared minus 8y plus 16 equal to 6.25 when I square 2.5. And then bringing everything in one side and combining the like terms, I get x squared minus 2x plus y squared minus 8y, 16 plus 1 is 17, minus 6.25 is going to be 10. So let me first write in plus 17 minus 6.25 so that we understand what's going on. And then x squared minus 2x plus y squared minus 8y, and 17 minus 6.25 is plus 10.75 equal to 0. So that's the equation of the region that is bounded by the circle that will receive the transmission sent from the location 1, 4. Answers our question. This also concludes the study of circle for us. So it is a pretty simple section. There are a few homework problems that you want to try. So keep working on your homework problems. Let me know if you have any question.